Hi everyone. I'm Tom Jew. I am the Overseas Consulting Engineer of Signrock. I'm very happy to introduce our company's equipment to everyone on this occasion. Next, let us understand the pit technology in detail. This is the basic principle of pit testing technology. According to the schematic diagram on the left, we can see that when we use a hand hammer to hammer the top of the pile, a stress wave pulse will be generated and transmitted downward from the pile body, which will reflect on the position of the pile body defect or the position of the bottom of the pile. The reflected wave propagates up to the pile head and is recorded and received by the sensor, forming a curve. We can see a schematic diagram of the test results below. By analyzing the characteristics of the curve, the integrity of the pile body and the severity of the defect are evaluated. The theoretical model of this method assumes one-dimensional homogeneous linear elastic members. First of all, our understanding of one-dimensional is that the ratio of pile length to diameter should be greater than 10. For example, a pile with a diameter of 1 m and a pile length of 2 m is not suitable for pit testing. The understanding is that the rod is made of a material and can be restored to its original shape after deformation, which is in compliance with Hooke's law. In other words, all piles that meet this characteristic can be tested for low-strain pile integrity testing. These are the types of problems that can be detected by pit methods. For the following common types of defects, low-strain testing can have obvious responses. Pile bottom, mud empty hole, fracture, isolation, expansion, shrink, soil layer change, material change. This is a schematic diagram of the propagation law of the stress wave in the pile. As you can see, the stress wave produces emission waves at the position of diameter reduction and expansion. The basic law is that when there is a diameter reduction at a certain position of the pile body, the wave impedance value of the pile will become smaller, resulting in the same direction reflection wave. When the pile body has a diameter expansion at a certain position, the wave impedance value of the pile will increase and produce back reflection waves. And we can obtain the time difference of the reflected wave from this, combined with the stress wave propagation speed, to get the specific location of the defect. This is an on-site testing case. These are two pit testers sold by Signrock. One model is Rsm Pit Device, which is a conventional low-strain testing equipment. The other is Rsm Pit. We can see, the picture shows that it has two test channels and is a high-profile version of low-strain equipment. Why choose Rsm Pit Device? 1. Dual-channel sampling, multimode testing, assessing unknown foundation length. 2. Accurate sampling and on-site analysis, accurate to 0.01 m. 3. Multi-hammer superimpose and signal average can be realized on-site. 4. PIT, RSM mode optional. 5. 10H long standby. 6-20 plus 55 fearless of the extreme environment. 7. IP65 dustproof and waterproof. 8. Both Chinese and English is supported. This is a comparison between Signrock pit equipment and the American PIT equipment. Judging from the curve displayed in the equipment, the response effect of Signrock equipment to defects is more obvious, just like the part marked by the red circle. The models are Rsm Pit R and Rsm Pit P. Our speech is over.